Hi, this is Start with 3D Modeling channel, and in this video I would like to show you a few things that may not be entirely obvious at first when it comes to creating 3D models in Plasticity. Here, as you can see, when you launch Plasticity, the menu and appearance of the software is not typical compared to other similar programs. We don't have a standard menu, we don't have ribbons, we don't have too many icons, but I wouldn't want you to be misled by that because the methodology and workflow in Plasticity seem to be really well thought out. After mastering some basic issues, you can quickly create 3D models and also quickly select the commands you want to use. At the beginning, what catches our attention is that we have several commands for creating flat geometries or simple 3D solids. Here we can create 3D primitives or simple 2D shapes. We have a few icons, but these are not all the available commands we have in Plasticity. If you want to see a list of all commands, click on this button. Here we have access to all commands, and as you can see, some commands have information about keyboard shortcuts. Using keyboard shortcuts and invoking commands with key combinations or using selected keys is really very fast and very convenient. As for this list of commands, we can activate it by pressing the F key on the keyboard. Then, wherever the cursor is, a list of commands will appear. From this list of commands, we can select a command. We can also enter the name of a command here, and based on that name, select that command. This may seem like a rather strange solution, but it is really very convenient. When I started working with Plasticity, many things could be done very quickly. This program really allows for quick creation of 3D models. Now, as for selecting geometries to draw, as you can see there are small arrows next to some commands, which means that there are additional hidden commands here. To activate the additional commands, just hover the cursor over that command and press and hold the left mouse button. Here we have additional commands that we can choose from. How to select such a command from this list? Hover over it, hold it, and then hover the cursor over the selected command. Release the left mouse button, and that command is active. So, as you can see, at first glance it may not be obvious, but we can easily select these commands. Now, if I have an active command, I press escape, and that command has already been cancelled. Let's now proceed to create some geometry. We will draw a rectangle. I would like to place the first corner of the rectangle at the origin of the coordinate system. As you can see, a snap has appeared. I have active snapping. I have snapping to objects here, and a characteristic object is the origin point of the coordinate system or some axis of the coordinate system. As you can see, snaps appear, and I can link the point with the selected axis or with the origin point of the coordinate system. Now, I want to place the corner of the rectangle at the origin of the coordinate system, so when this snap is active, I click the left mouse button. This rectangle will be drawn in the XY plane, but we can, for example, change the view to the XZ plane. And now we are creating a rectangle in the XZ plane. We can do this right while drawing the geometry. Now I close this plane, and we return to drawing the rectangle on the XZ plane. As for rotating the view, we do this by pressing the mouse wheel, and we can rotate the view. And when we switch to a selected plane, here too, if we press the mouse wheel, we will rotate the view and return to drawing the rectangle in the XY plane. And so, here I have the drawing of the rectangle, and while drawing this rectangle, we see what dimensions this rectangle will have. A helper line has also appeared. This means that if this line is active and we draw the rectangle in such a way, we will create a square, that is, the sides of the rectangle will be equal. But if we want to specify precise dimensions for the geometry, we need to press the Tab key. I press the Tab key and I can enter a specific length for this side, for example 100 millimeters. Now, to determine the length of the second side, I press the Tab key again, and here I enter a specific value, and at the end I press Enter to confirm it. Now, one more thing regarding creating flat geometries, and something that at first might cause mild confusion, is precisely determining the position of the geometry relative to another geometry or relative to the origin of the coordinate system. Now, I will switch to the top view to have a view of this rectangle. I would like to draw a circle that will be offset 10 millimeters from this corner to the inside of the rectangle. I would like this circle to be offset by 10 millimeters along the x-axis and 10 mm along the y-axis. I select the drawing of a circle and choose to draw a circle from the center. As you can see, we do not have the ability to specify the exact position of this geometry. We can do this in such a way that we draw geometry in this corner. I will draw a circle with a diameter of 15 mm, so I press the Tab key, enter 15, and press enter. We have drawn this circle, and now we can move this circle by a precise value along the x-axis and along the y-axis. To do this, we activate the move command. This is the move command, which we can activate by clicking this icon, or we can press the G key on the keyboard. We select this command, and now we can specify the offset values along the x-axis and along the y-axis. We can do this precisely, for example, by entering these values in these fields. Now I will move by 15 mm, so I will enter -15 here. I press Tab to switch to specifying the offset in the second direction, and I also enter -15 here. Finally, we accept this offset, and now this circle is precisely offset from this corner. We can do it this way, or we can also create some auxiliary geometry. I will now draw a line, and I would like to draw a circle that will lie in the center of the rectangle and will be offset 20 mm from this edge. As you can see, we have a snap that defines the center of the line. I click here to start drawing the line. Now I drag the cursor in this direction to indicate that I am drawing the line this way. I press the Tab key, and here I enter 20 and press enter. We have created this auxiliary geometry, and now I select the drawing of a circle. I place the center of the circle on this line, and for the diameter of the circle I enter 15 mm and press enter. Now this geometry is not needed, so I select this geometry and press delete to remove it, and this is how we can precisely determine the position of the geometry relative to another geometry or relative to the origin of the coordinate system. We simply use either the option of moving the geometry or using auxiliary geometries. Now I will return to this view, and so we have here a flat geometry. However, as you can see, when I hover over this geometry, it becomes highlighted. Another important thing related to creating 3D geometry in Plasticity is the geometry selection modes. Here we have 4 selection modes: vertex selection mode, edge selection mode, face or area selection mode, and solid selection mode. We can activate these modes by clicking on the selected mode, and now, as you can see, I have the vertex selection mode selected, and I can only select vertices. Next we have edge mode, where I can select flat geometries. Then we have face mode, where I can select areas bounded by some flat geometry and faces, and we have solid selection mode. Here we don't have any solids, so I cannot select any solids. These modes can be activated in such a way that we choose them individually, or we can select all modes so that we can select all geometries. As for choosing these modes, we can do it by simply clicking the cursor on the icon with the selected mode, and then that mode will be active, or we simply use the keys on the keyboard. Key 1 is for vertex selection mode, key 2 is for edge selection mode, key 3 is for face or area selection mode, and key 4 is for solid selection mode, and key 5 activates all selection modes. So, here I will select the area selection mode, and now when I select this area, the extrude command has been automatically activated, and with this command we can create a solid based on this flat area. To do this, we simply drag this gizmo and specify the extrusion length. We can do this freely, or we can specify a precise extrusion value. As for specifying a precise extrusion value, we can do this in this field. I can, for example, enter the value of 25 here, click OK, and the extrusion has been added at a height of 25 mm. We can check that too. I will switch to edge selection mode. When I select this edge, we have information about the length of this edge. Here, while selecting the edge, the fillet command has been activated. We will get back to that shortly, but for now, I will undo this to return to the flat area. I will switch to face selection mode, select the area, and the extrude command has been activated, allowing for the creation of a solid. Now we can also specify the extrusion value precisely without using this window. We just need to press the D key to specify the length of extrusion. and now we enter the value of extrusion, for example 30 millimeters, and press enter and enter again to confirm this command. In my opinion, this is very convenient. You can create 3D models very quickly. Once we master the basics of creating 3D models, after creating a few of our own 3D models, we can quickly master the keyboard shortcuts, and it becomes a really convenient solution. Of course, these are subjective feelings. Not everyone may like it, but for me, it's a really interesting and cool solution that allows for quick creation of 3D solids. So here we have created a 3D solid, and I will switch to Edge Selection mode now. As you can see, after selecting the edge, the fillet command has been activated. As for selecting the edges we want to fillet, we can select several edges using the Shift key. Now, to add a fillet, drag this gizmo in one direction, and if we drag it in the other direction, a chamfer will be added. If we want to specify the fillet or chamfer dimension precisely, we can do this in this field, or we can use the keys. By pressing the D key, we specify the radius value. For example, I will enter 10, OK, press enter, and enter again to confirm. Now I will select these two edges with the Shift key, and here I can specify the chamfer dimension. To specify the chamfer dimension, press the C key. I will also enter 10. OK, enter, and we have added chamfers. Now, one more thing that might not be entirely obvious at first. We will create another piece of this solid. I will switch to face selection mode, select this face, and press the spacebar so that this face acts as a temporary construction plane for creating geometry. I will create a rectangle geometry of any dimensions, but here I connected this corner of the rectangle with the edge of the solid. I close the temporary construction plane, and here we have created such a rectangle. I select this rectangle, add an extrusion of any value, and click OK. Here, what you can notice is that a second solid has been created. These two solids are separate solids. They are not connected to each other. I activated the move command to move this solid to show you that they are separate solids. Now this solid is selected, so I press delete to remove it. That's how we can add extrusions. I click OK. We have two separate solids. We can combine these solids. We can do it by holding the Control or Command key and selecting the two solids in the outliner, or we can switch to solid selection mode and select these two solids in the workspace with the Shift key. Activate the Boolean operation, which allows for joining or subtracting solids. To add the solids together, choose the union operation and click OK. Now, these two solids have been merged into one single solid. I will go to Outliner. Here we have an eye icon that allows toggling the visibility of the geometry. We have solids, and here we have flat geometries. If we click here with the left mouse button, all geometries will be highlighted, and if we click the eye icon next to one of these geometries, the visibility of all flat geometries will be turned off. Now I will undo this to return to the moment we added the extrusion of this solid. I will just select this solid and delete this solid, and I have flat geometry here. I add an extrusion, and when adding the extrusion, we can immediately specify that this solid should be connected to that solid. We just need to click the Q key and now select the solid to which this solid should be attached and click OK. Now it is one single solid. I will undo this to return to that moment. And here we have flat geometry. Now we can cut material from this solid based on the flat geometry. To do this, we simply drag down. However, if we do it this way, I click OK. Here simply another solid has been created and no material has been cut out. We can do it by selecting the solid we want to subtract from, then holding the Shift key, selecting the solid we want to subtract from this solid, and activating the Boolean operation. Here, the diff operation, which represents the difference between two solids, is automatically selected. I click OK, and we have created something like this. Material has been removed. I undo this. Now I will delete this solid, and we have a flat area. While adding an extrusion, we can also specify that we want to remove that material from this solid. We have the difference operation here. We press the W key on the keyboard, select the solid we are subtracting from, and click OK to confirm. That's how we can remove material from the solid. Now I will show you another trick. I will create any geometry here, and I would like to add the extrusion of this solid to the height of this face. To do this precisely, if we know the height of this face, we can enter a specific extrusion value, but if we don't know, we can simply press the Control key while adding the extrusion and hover over some geometry that is at the height of this face, for example, this point. Here I release the left mouse button, release the Control key, and the extrusion has been made to the height of this face. I will undo this and again select, press the Control key, add the extrusion, and here I will add the extrusion to this point, or we can add the extrusion to the middle of this face. As you can see, by pressing the Control key, the snaps that facilitate the addition of extrusion at a specified distance were activated. I click OK, and in this way we created something like this. But again, this solid is not connected to this solid. I switch to solid selection mode, select this solid. With the Shift key, I select this solid, press the Q key to activate the Boolean operation, press the Q key again to activate the solid, joining here, click OK to confirm. I will turn off the visibility of the flat geometry, and we have such a solid. These were very basic issues that I wanted to point out. I am a user of typical 3D CAD systems where we work with features and parameters, where we create a parametric model. Here in Plasticity, a direct approach to 3D modeling has been applied, and these methods of approaching 3D modeling differ from each other. For people with experience in parametric 3D CAD systems, working with Plasticity at first might not be so obvious, and it may seem that this system is not well thought out. However, in my case, such feelings that Plasticity is somewhat complicated were only at the beginning, until I learned the methodology of working in this system. Therefore, in my opinion, it is worth going through some tutorial at first. It is worth creating a few sample models following some tutorials, and later I suggest starting to create your own 3D models, because especially if you have experience with parametric 3D CAD systems, working in Plasticity at first may not be so obvious. I believe that many people, after checking out Plasticity and creating a few sample 3D models, may like this program because, as I mentioned, we can create 3D models very quickly and quite easily. I'm recording a few more things now because after recording this video, I realized I haven't said everything yet. One significant issue is the matter of changing dimensions. If you have already created a model in Plasticity, as you can see, we don't have an operation history here. Unlike parametric 3D CAD systems, we cannot make changes to parameters, but that doesn't mean we can't modify the solid. For example, if you want to change the diameter of a circle, switch to face selection, select the face of the circle, and here you can drag this gizmo and the diameter of the circle will be changed. You can enter a specific value by which you want to change the diameter, or you can simply select the face of the circle and, after pressing the equal sign on the keyboard, enter a new diameter value. Similarly, we can change other dimensions. Here, I simply select this face and I would like to move it by 5 mm. So I enter -5, hit enter, and this face has been moved, and this dimension has been changed. Next, regarding the distance of this hole from the edge of the solid, we can do this using the Move command. That is, we select the face of the hole and press the G key. Now we can move this hole. Of course, during this Move command, we can enter a specific value, but we can also add a dimension here. To do this, we activate the dimensioning command, and it is the Measure command. Press the F key on the keyboard and type Measure here. We can activate this command by pressing the keyboard shortcut Control plus the equal sign. Now I specify the distance from the center of this hole to this edge. This distance is 26 and a bit, as we have moved this hole by an unspecified value. Now, when I select this hole and activate the Move command, if we change the position of this hole, the value of this dimension will change. We can simply specify a specific value by which we want to move, or we can do it in such a way that we select the face of the hole, activate the move command, and this dimension is highlighted. Now we click on this dimension with the left mouse button and enter the specific value here. This way we can specify the distance between geometries. The same can be done regarding the distance between holes. I press the keyboard shortcut Ctrl plus the equal sign and specify the distance from the center of this hole to the center of this hole along the x-axis. I select this hole, activate the move command, and here I enter, for example, 50 millimeters. Hit enter, enter again, and this distance has been changed. Similarly, we can do this concerning a pocket. I press the keyboard shortcut Ctrl plus the equal sign and specify the distance, for example, from this point to this point. Here we also moved this face, and during the creation of this pocket, we did not specify dimensions. I select this face, press the G key because in this case, I will be moving this face, and I change the value of this dimension to, for example, 35 millimeters, and hit enter. This way, the distance between these faces has been changed. This is not something we know from parametric 3D CAD systems, but regarding CAD systems that use direct modeling, what we have in Plasticity is a really great solution and offers enormous possibilities for creating precise 3D models. We can create 3D models with precisely specified dimensions because we can specify exact dimensions here, and even after we have created a 3D model, we can precisely change those dimensions. In certain situations, it may turn out, as in the case of this pocket, that if we want to do it symmetrically, we may need to move one face and then move the other face, but to some extent we have the ability to make precise changes to the geometry. This is also useful, and for beginner users, it may not be entirely obvious, which is why I wanted to include this information in this video. I will finish this video here. I encourage you to check out other videos on this channel where I demonstrate selected operations of plasticity on sample 3D models, and we simply create a 3D model step by step. You can check whether plasticity will be suitable for you or not. Plasticity has a 30-day trial version. You can download this program and test it, and if you decide to purchase this program, with my discount code, you will get a 10% discount. Thank you for watching, and please subscribe to this channel.